Okay, so in this session, we want to quickly cover both functions and number patterns. You are working, guys, not me. All right. So the first one that you guys have been battling with, let's try to get it done. The diagram below shows the graph of, I'm going to be fast on because some of the concepts we all know how to get them. Okay. So we have f of x, which is a parabola, a hyperbola, and g of x is a parabola, right? Lovely. The two graphs intersect at point T, which is the y-intercept of both of them. Blah, 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 blah. Write down the coordinate of T. All right. We can see that T lies on both graphs, but there is not much information on F. Can we then, guys, when they say write down, don't even start calculating. What's your answer for number one? 0, T. Our x is 0, y. It's the y-intercept. And we have 3. Did we all get that? Please. That one, there's no negotiation. Calculate the coordinate of P. What is the coordinate of P? There is the turning point. Okay. So, x of P will be what? Minus B over 2A minus 10 over 2 multiplied by 5. What's your answer? Negative 1. Make sense? Now, what is the y value? 5 into negative 1 squared plus 10. Do you want to give me an answer quickly there? Quickly. Negative 2. All right, so what's the coordinate of P? Negative 1. All right, number 3. Write down the equation of F. Now they want the equation of our hyperbola. F of x therefore will be 5 over x. Give me your answer here. Now we know this value here, our turning point x is what? Negative 1. And this one is negative 2. But remember, it's the x. The sign must change. So what do we have? Plus 1. Number 4. Determine the equation of the tangent to G, touching F at T. To G, touching F at T. So there's a tangent here. What do we know? Guys, I told you when you see a tangent, bring in, look, you're grade 12. Grade 11, I'll say use nature of roots. Okay? But in grade 12, just bring in calculus immediately. Don't even waste time. Anytime you hear the word gradient, what are you saying? F prime of x equals to what? M. But this time around, which graph are we using? G. So can we say the G prime of x is equal to what? M. Can we derive? Talk to me. 10x plus 10. We are looking for the equation, but do you think we can get x here? No, we have our x value. What's the x value? 0. So what is M? Lovely. Okay, so what's our equation? Y equals to what? 10x plus 3. There's no need to calculate. C is the y-intercept. We're done there. So please, immediately you see the word gradient, you hear the word gradient, please think about the first derivative being equals to what? Gradient. Is that okay? First derivative equal to gradient. Let that reign. Try that first. I could do this with nature of roots, but there's no time for now. Nature of root, I will have used b squared minus 4ac equals to 0 because the roots are equal at that point. That's grade 11. Axis of symmetry of f with a positive gradient. That one is now simple. Number 5. Y equals to what? X plus 1 minus 2. Y equals to x minus 1. Guys, here is what the examiner is asking you. That. Yes. Axis of symmetry of f with a positive gradient. We are done. What did you guys do? And then you started doing what? Okay, that's it. There's nothing else to do. If it's a negative gradient, then we put negative there, right? Now, I don't know if I showed you this last week. I think we did. If they give you the equation of the axis of symmetry, you can find your asymptotes. Know that? Did it? Okay. Can I do that quickly before I jump? Check. What's this equation? What was the equation we're given? Y equals to what? 5 over x plus 1 minus 2, right? So the one with the positive, what would it be? Y equals to x plus 1 minus 2. That's fine. The one with the negative gradient, what would it be? We throw in our negative there, right? So the denominator is multiplied by negative. So negative x. So what's our answer? All right, now check. The examiner would give you these two equations saying the axis of symmetry are those. Find their asymptotes. All you need to do is to equate them, because that is a point of intersection. So x minus 1 equals to minus x minus 3. Bring that there. 2x minus 2. What is x? Now, what is our y? Y is x minus 1, right? Check. Negative 1 minus 1. If I tell you to write down your asymptote here, what would you have written? X equals to negative 1 and y equals to what? Negative 2. So please take note that when you're given axis of symmetry like that, equating them gives you your asymptotes. Okay. So we're good. The last one is where things went a little bit south. Okay, but let's see. Let's see. It says determine for which values of x will g prime of x. Now, I know, but this is easy. I thought they're asking you for the gradient of f of x. Prime of x times f of x. Guys, now this question is... All right, let's see quickly. If we say g prime of x, the gradient, let's go to g. G is the parabola, right? What's the gradient here? Negative. Negative. Gradient here? 0. What about here? All positive, right? Good. Now, they said f of x. Let's go to our f of x. What's the value of f of x here? Negative. Value here? Positive, positive. What are we looking for? G prime of x, that is 5.5. G prime of x multiplied by what? F of x is less than or equal to 0. Now, if we want to get something less than 0 and we are multiplying, it means they should be of opposite signs. When this one is positive, this one must be. When this one is negative, take a quick ruler and work things out. That's my ruler. What sign am I touching here? They are both negative, by the way, because this graph continues up. I don't want them to be both negative, so this one is not going to work for me. Right? I need one to be positive and the other one to be negative. But I need 0 too. Is that okay? Because they said muscle must be equal to 0. So definitely I need x equals to negative 1 first. Because at negative 1, the gradient is equal to what? So every point I wrote 0 is important. Okay, let's continue. What signs do we have here? Both positive. Do you see the blue is positive, the red is positive? Do I need that? No. We continue again. I need that R. With the x what? Intercept. But from there on, do you notice it's positive and negative? Because this sign here continues to be what? Positive. So basically from R going that way. Can we get R? What do we know about R? R is the x-intercept of your hyperbola, right? Of the hyperbola. We need to show the calculation. Y equals to what? 5 over x plus 1 minus 2. What do we know? Our y equals to what? 0. 5 over x plus 1. Can I move the negative 2 over? 2 equals to 5 over, what do you do here? Never. Just time for cross multiply. Just switch those things. That. And then move the 1 over to give you negative 1. 3 over 2. This point is what? 3 over 2. So what's my answer? X is greater than or equal to what? 3 over 2. X is an element of real numbers. We are done there. All right. I hope it makes sense, guys. Total is how many? 4. I'll see. Okay. I hope it makes sense, guys. Now, what if I thought the examiner was asking you something? What if the examiner says for you to derive a hyperbola? How are we going to get it? Skip. Next question. Let's try it quickly. It's not difficult, guys. Look, let's create a question. Let's just create a very random question. Okay, I'll try to use the same one, but do some. Okay. Add this, right? Oops. Add this. Add that. F of x, right? Okay. Let's create. Okay, and we had one which was. Now what? G. Now examiner says, check this. Which values of x will, I hope I'm going to create something nice. X multiplied by g of x greater than 0. They're going to be thrown away by looking at, that's a hyperbola. How do we derive a hyperbola? Very simple. What does this stand for? Right? Now, gradient requires you to have 2 points. If I look at this hyperbola, check this hyperbola. If I want to find the gradient, I need a point there and I need a point there. Let's draw a line. What type of gradient is that? It's a negative. We are done with that one already. I create 2 points here. What's the gradient? So already we are done. Gradient, it means for this particular graph, this one will permanently be negative. That makes sense? It's called gradient. So all we need is to find where this one, since we want this part to be positive, what do we need? We need where this one is also what? Negative. Oh, so it's right here. That's where my answer lies. But then you exclude the asymptote. So x would not be. So for example, if this was negative 2 and this was 1, and our asymptote here is what? Negative 1. Okay, negative 1 is here. What will our answer be? X lies between what? Negative 1, but x cannot be equal to what? And that's it, guys. Don't let it rattle you. If you have a hyperbola that looks like this, what do you think the gradient of this one would be? Line there. All right? Do you see? What's the asymptote? What's the gradient? Positive. Then you Find the other part, and we're done. Are we okay, guys? Okay, beautiful. That was a good starter. I don't know if I want to do. Okay, we've not done exponential and log functions. Let's quickly try that. 9 marks. Guys, you have 7 minutes. For the first time, please beat the time. The time, 7 minutes. Are we done? Should be done, guys. All right, done. Kuvadia done. Which one is difficult? What did you find difficult? What did you find difficult? Nothing. Your eyes are okay. Awesome. What did we find difficult? Maybe 6.4. Vadia, you want me to smack you? Alice. All right, guys, quickly check. We have a graph, and there's something I want to tell you here. I hope, even if it's not in this question, please, I'm going to mention it when it comes to log graphs. We have y equals to what? 1 over 3 to the power of what? X. What did you get for the value of k? Already we know that k is y, right? 1 over 3 to the power of what? Negative 2. What is k? 9. We're done there. Determine the equation of the inverse. Okay. What do we know? Inverse. Anywhere we see x, we put what? Y. So already, can we inverse it? X equals to what? 1 over 3 to the power of what? Y. Guys, if the examiner wants to ask you for inverse, sometimes they will not use y equals to x. Okay. Inverse means a reflection. Reflection along the line y equals to what? X. All right. How do we then do this? We bring in what? What are we going to have? Y equals to what? I want to beg you, don't leave your answer like this. Correct. But I then throw some inequality question. Log base a x, please write it as negative log very, very important. 1 over 3, I'm going to change the 1 over 3 into what? 3 over 1. If I do that, this answer then becomes what? Negative log 3. Please. Very important. I'll show you where this will be a problem. Once you see an inequality sign, we are going to have a big problem. Okay, draw the sketch of G inverse. This is one of the easy. Guys, I want to show you a quick way to sketch this thing. A very quick one. The first thing is you are going to inverse your coordinates. Right? A is negative 2, 9. What am I going to draw? 9 and negative 2. Okay, so and negative 2. My graph will definitely pass there. Here's one thing I wanted to see. This graph, let me use a high, close to positive. Very close to an inverse. Graph is very close to the positive y. This point, what is this point? Pass through what? 1 at that point. That point that we have. this point? 9, and check how we quickly got x. It must be close to positive 1. Clearly show the intercept with the axis. You see, we have there clearly also as one of the points. All right, consider the graph H, which is G. Values of x will da 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 da. Can I move to the next? Can I create a new page? How do we interpret the last? Consider h of x. The examiner is referring to the inverse. How many units? 2 units. I shift the graph. All right, but they said they want this graph to be greater than what? Negative 1. Graph. This entire graph is shifted. That means my new graph then looks like this. Graph is not like this. Now we want this graph to be above. Graph should be above negative 2. But the question is, what is the x value at that point? One thing that I know is, first, my asymptote was 0. Backwards, I'm with you. So my answer is between negative 2 and a particular value. Ready? 7. How did you get 7? 9? Why did you say 9? I've shifted 2 units to the left. Let's do something. Yeah. What was it? 9 and huh? 7. You sure? All right. Remember, guys, this is the x value. And the x. How many units backwards? 2 units backward. But I'm just sketching to show what the graph looks like. Definitely, this graph, this point then becomes what? The range. It's now between negative 2 and what? 7. We are done there. Negative 2 x less than what? 7. That makes sense, guys. Please, if you don't put that negative 2, where is it? Okay, equal to what? I want us to try something quickly. Let's try algebra. I'm not advising you on this. What is our g prime of x? I'll just show you something quickly. All right, our g prime of x is what? Log base 1 over 3, right? X. Watch this, everybody. Now, if I then say g prime of x plus 2, what are we going to have? Log base 1 over 3. This one becomes what? Okay. This should be less than what? Negative 2. The idea is that this thing would come here. I need us to walk through this. Let's do this again. Log 1 over 3 x plus 2 is less than, is it less than or equal to? Than or equal to what? What is ideal for any learner to do? Might be having a problem. What will this give us? The answer we have on the graph. X is less than 7. Calculation-wise, x is greater than 7. What did I say about negative 1 over 3? Log 1 over 3 x plus 2 should be written as what? What do we now have? Negative log base 3. But greater than or equal to what? Divide both sides by negative. What are we going to have? Log base 3 x plus 2 less than. Do you see now that it's now coinciding with our graph? This is why that 1 over 3, a fraction base, please change it to negative. What do we have? X plus 2 is less than or equal to what? 3 squared. X plus 2 is less than or equal to 9. Now I cannot walk through this. Go back to the graph. The graph has an asymptote. And what's the asymptote? So please take note of that 1 over 3. Is it making sense? But guys, have you taken note of that 1 over 3? So this one is completely what? Wrong. The problem is that they've removed what IEB students do. You see the way you have what laws of exponents. There are laws of, that's a law of log. Log, if it's A over B, change it into what? A and introduce what? A negative. Write us on inequalities. Can you hear me now, Ricardo? Is it fine? All right. We're just touching base. Similar stuff here. Similar stuff here. Do you see again? It's going to affect us at 5.6. All right. But let's see. I want us to like to do this. Like to do this. There's something interesting in 5.7. Are shaking their heads, and when you shake your head, guys, I'm giving you 6 minutes. Try everything. Not what you mean 5.7 only for the whole thing. 6 minutes. Okay, 7. Come, let's push. Okay, I'm starting again. 8. So we can at least touch on number patterns again today. At least, guys, I'm expecting, you know, last question is algebra. There's no. I'm up, right? Guys, you see, it's possible. Most of you are. Okay, quickly, let's see. Which one was difficult? Were you able to write down the coordinate of Q? What's your answer? Give me your answers quickly. We just want to write answers. What's the answer of Q? All right. Number two, what's the value of A? Sorry? Guys, if your answer is different, please let me know. Is A 2? Okay. Number three, inverse. Log. Log. So we say Y equals to what? Log base 2x. Fine. Do we agree? Okay. Or sketch the graph. Again, I'm going to sketch the graph here. Since we have a 0 and 1, what do I need? A 1 and 0. The graph is moving towards the negative x. Half and negative 1, which is some and negative 1. We have write down the domain of the inverse. What? 5. What do you think? What would be the domain? X values. X is greater than 0. Number 6. Hence or otherwise, determine the values of x for which log base 2 of x is great. This one is straightforward. Remember, it's a base. It's 2 to the power 1. X of x equals, is this what you guys are crying for? They said h of x is equal to what? G of x. What is h of x, by the way? Power x, right, is equal to what? 100 multiplied by 3 to the power x. Divide both sides by 3 to the power x. What do you? Done this. We did it under exponents. We did it under statics, chemical equilibrium. So what do we have? 2 over 3 to the power x equals to what? 100. I am looking for an exponent. What do I bring in? Logs. So x equals to what? Log base 2 over 3. Answer. The answer must be negative. Understand where this negative came from. I promise you, guys, if you check your calculator, log 2 over 3 same as negative. Can you confirm this for me? Negative 3 over 2. Remember the law I taught you? It's the same. We're done. That's where the negative came from in terms of logs. So more algebra than that. Okay. So guys, when you are working and practicing, please don't relax. That pressure of time. I'm sure. Look, if I gave you 15 minutes, you'll still be busy. Right? If I gave you 30 minutes, you'll still be busy. Did it under the time frame that I. Well done, guys. Okay, quickly. 2 marks, please. 2 minutes here. What is here? 3 minutes, 30 seconds for you to read. Sorry guys, I don't know. Maybe I just need to charge. Let's just manage for the night. My mic. but I hope you were able to get the information. I don't know why the mic is breaking. In the next 2 minutes, everybody must be done. Thank you, Kuvadia. Done. And I hope the sound is better now. Ricardo, is it better now? Lufa done. Beautiful. Tuto done. Kato done. Pancho done. Okay, let's just save time, man. Is this convergent? What is the where do we get convergent from? Value of r. R must be between -1. Get r here. T2 over T1, right? 1 over 15 divided by 1 over 5. What's your answer? Convergent series? Yes. You must, guys, there's mark for that, yes. Why? Because r lies between what? Negative. One over 3 lies between -1 and 1. Fine, but as long as we see your r. Guys, and that one is done there. I 0 over 2. Because if you say no, there's no way. Calculate the sum to infinity. Eh? No, there's not consistent here. A dog? Yes, then you give a reason because I'm backing. Consistent accuracy. Does it make it right? Okay. Sum to infinity. A over 1 minus r. What is our A? 1 over 5. Over 1 minus. What's your answer? Over 10. Guys, simple stuff like this, no errors. There's no error. All right. Check this quickly. Now, we are now bringing out the real guns now. 10 minutes? No. 7 minutes. All right, guys, let's quickly check. All right. It says an arithmetic and a geometric, guys. Once you see them combining, know that we're working in pairs. Okay. Write down the next two terms. What's your answer? 4x and 1 over 81. Is that fine? Everyone should get that. 2.2.1, it's 4x and 1 over 81. Determine the general term for the odd terms of this pattern. Which ones are the odd one? Look, once you see that, let's quickly write the odd pattern out. It is x, it is 2x, it is 3x. That's the odd. 135. What's our general term? It's an arithmetic, right? What's the difference? X. So it means my Tn, I start by writing the difference. X or nx. We agree. Calculate the value of the 26th. Now, the 26th is uneven. Becomes the 13th. Your second pattern. And what's the second pattern? Have 1 over 3, 1 over 9, 1 over 27. What are we looking for? We are looking for what? 13. Right. What is my T13 will be equal to A R to the power of what? 12. What is A? 1 over R. To the power of what? What's your answer? 59. 432. Do we all agree? Okay, done there. So 2.2.4. If the sigma notation, the total is how many terms? How we get the number of terms? Top minus bottom plus 1. That entire thing is 33,5. We have 21 terms. Guys, if we have 21 terms, first one being what? Arithmetic. First is to understand we have 10. Okay, we have 10 of this. But after the geometric, then comes what? The arithmetic, which is the extra one, which makes the arithmetic to become what? 11. So the sum of the first 11 arithmetic, all right, of, let's just say S11 arithmetic plus S10, the geometric, should be equal to what? What's our formula? Right? N over 2 n minus 1d. That's the sum of plus sum of the geometric a into bracket r to the power of n. Everything should be equal to what? That makes sense? Okay, let's deal with it. What is our n here? 11 over 2. What is our first term? X. Our first term is what? X on the arithmetic. How many terms? 10. Our difference. Plus, what is our A here? Power of what? Okay, let me use the power of 10 minus 1. X plus 10x divided by 2, 6. So what do we have? 66x. Guys, I think you can take it from here. Huh? Post your calculator there and get an answer. Khaled was interpreting the psalm, which is not very. Makes sense, guys. All right. So, guys, if we continue with the way we are doing, start, we actually doing well in terms of. We might be focusing on calculus and whatnot and forget number patterns. That's not going to be acceptable. Do you want to try this as a final question before we go? Same paper. You did this one. Okay. This one you have 5 minutes. Yes. How emotionally to blackmail me. Five minutes. What's going what's going on? All right, I won't mind you. What a wow. Let me know once you're done. Question for you to just. All right. Manage? Huh? Be able to get Tn. If you get Tn, then the last question is just... all right. The second difference is 10. The first 1 plus T2 plus 3T is 28. What do we do there? A is equal to 10. A is first two terms are equal. A plus B equals to 0. Divided by 5 plus B. What is B? Negative. Right? The last one, the C, is the problem. But we know T1 plus T2 plus T3 equals... we do know T1 plus T2, right? Huh? Sorry? Okay. 2T1 plus T3 equals to 28 minus 2. How does... Okay. The examiner told us the second difference is what? Basically, this is what we're saying. T1, T2, T... difference here is equal to what? Minus T2 is equal. And what is T2? T1. 8 minus our T3, right? Okay, let's write it nicely. What is T3? 28 minus 2T1. That is just T3. Minus, yep. Are you okay with T3 minus T2 is 10? What is T3? 28 minus 2T1. Fine. All right. Now, what is T2 itself? That is equal to what? 10. Make sense now? All right. That is negative 3T1 there. Space there. So what do we have? 28 minus 3T1 is equal to minus 3T1 will be what? Negative 18. What is T1? 6. That is A plus B plus... we have A, 10. Right? What is 10 minus 15? That give us what are we supposed to prove? Am I making a mistake? Did I make a mistake somewhere? Yeah? But we're fine with this and 15, right? Let's right. I was trying to save page. Let's see. 1 second. Eh? What is our A? Oh, that's where the error is. Yeah. Our A. 5. 5 minus 10 will give us what? Negative. That 10 there, see, it will be equal to what? Whatever method, as long as we get that. Our Tn. 5n squared minus Plus what? 16. Last question for the day. Oh, is 216 a term in this sequence? Find your answer. So we are going to say Tn is equal. Let's find if Tn can be equal to 100. N is equal to 216. So we say 5n squared minus 50. 5n squared minus 15n. You want to give 100. Equals to what? 0. N squared minus 3n minus 40, 8 and 5. 5 and 8, but negative n equals to 8, or that's okay. T8 is equal to 2. Oh, is it part of it? Yes. Let's calculate. Delta. Why? Make it complex. And guys, oh, Semanke, which one should I re-explain? Which one should I re-explain? Okay, just go through here. I just saw your message. Okay, let's go through. I'm sure this one you'll find, this one you'll find. The whole idea, I think maybe if we had created a table, it might have been a lot easier. Okay. We had created a table saying we had, you know that table we create for 1. Probably it would have been easier. Okay. What is this? Right? Already, because these two are equal. The idea is to write it in terms of each other. 1 plus T2 plus T3. But these two are equal. So what we have, place it anywhere we see T3, which is here. What is T2? It is also equal. So that A plus B okay? Okay, did it make sense? So it's a matter of understanding and interpreting. Are we good? All right, guys. Good job. Good job today. We'll continue. Tomorrow, what am I doing? Applications there. Maximum and minimum. Try to look at all the different perspectives. All right. Have a lovely evening.